between regions and how can those regions with more food to share the food with those regions that are lack of food. However, so when I dig into that, I was thinking if there's any way that I can make those countries more self-sustainable, something like that, or how can I help them with. So I have changed my topic over time, and this is my new topic. This is my topic for my thesis. So my decision goal here is to find the best plans for countries that are having food security problems or are risking of food security problems. So this is my decision goal. So the first thing that comes into my mind, if a country have food security problem, then just grow more food. So, but to grow more food, we need more agricultural land. So to check if we can grow more food, I would need to look into how many agricultural lands they have. So the next is, however, even if we have lots of agricultural lands, like Afghanistan, they have lots of lands. However, some of the land are used to grow opiums or cash crops. So which means it does not really produce any food to feed its people. So here, maybe they can change the agriculture type, and corresponding to that is I need to look at the cropland percentage of the country so that I know how many percent of agricultural land is used to grow food. Then, so I have maximized what I have. Then, is there any better way I can do to produce more food? So the next is, so how about leverage the technology? Like Israel, for example, they have really good agriculture technology, and so they have something like precise farming, which can produce more food for man. So speaking of that, in order to leverage the technology, which means we need to invest a lot of money on technology. So here I will consider GDP per capita of the country. Then what's the next is, so if I have done everything and I can only produce that much of food, then what can I do next? Countries like Venezuela, so countries like Singapore, they don't have much land. All they can do is produce that much food, and 90% of its food is imported from its neighboring countries or its allies. So what they can do is to keep good international relationship. So in order to do it, then to see if a country, if it's dependent or not, I would check its self-sustainability. Then everything I have done, I have kept good international relationship with other countries to secure my food resources, and I have done everything I can do to grow more food. What's the next if I have no other choices? The last choice we can have is to influence the birth rate. Because some of the countries actually has a really high birth rate, which will double up every decade, and because of the fast growth of the population, the food production can never be enough for them. So it might be a good choice, or maybe an option, a possible option for them to change it, to influence its birth rate. And we will look into the birth rate here for our criteria. So back to the point, what I want to do for this research paper is to find the best plans for countries that are in need of help. So which countries are in need of help? So now I have a decision tree to help me to make this decision. So the first thing I would ask is, do they have enough food? So after doing some research, after doing a lot of research, so we found 2,212 calories per person a day would be a good number, not just for a person to survive but it's also enough for them to do exercise, to work out, to do all other things for this country to thrive. That's why we pick out this number. So if the country is above this line, then it's in good condition. And the other one is just have food security problems. However, countries like Singapore, they have a lot of food, but they don't really produce those food. So are they good? So what I'm going to ask the next is, are they self-sustainable? Otherwise, if they are not self-sustainable, they may be risking of like not being self-sustainable. Like if they just drop the relationship with other countries like Venezuela recently, they actually like run out of food. So here I have the index, which is S, and this indicates that self-sustainability. And how I get S is the food production get divided by 2212. So what I would get is if your S is above 1, which means you have the ability to produce that much of food, like to make your country to thrive. So if it's above that, then this country is in good condition. If not, this country have food security risk. So after doing this decision tree, there are 64 out of 167 countries that I am able to collect the data from are having risk, having food security problems. So this is the map. And the one in the black are those countries that I am not able to collect the data from. And most of the countries located in Africa and Middle East. The countries in East Asia or like South Asia are countries that well developed but not self-sustainable. So remember this. So since I know my goal and which countries are in need of help, I can do. Now I need to find which plans would be the most suitable for certain countries. So AHP here, how I would do it is analytic hierarchy process. This is a structured technique which can help me to organize and analyze complex. So to put it simple, AHP can help us to make a decision from a complicated problem. So to build an AHP model, we would need to have those criteria, like decision goal, criteria, and alternative. So there are 4 steps to build an AHP model. The first step is define pairwise comparison matrix. I will talk more about this because it's a conceptual stuff. And for the step 2 and step 3, I won't talk too much about it because like all this like for the normalization is like find the web vector, and for consistency analysis it's just like a math to check if it's consistent. So I won't talk about that here. And for the step 4, hierarchy ranking and decision making are the results of this model. So I will talk more about it. So step 1, define pairwise comparison matrix. So to define, so given A is a value between 1 to 9 and AJI is its reciprocal. So also we have the scale. This is proposed by Sadie, who creates this method. So if intensity of importance, A equals to 1, which is important, but is less than important compared to A equals 9, which will be super important, extremely important. So, yes. So when we construct this, it will become a comparison matrix. Also this is the scale table we use to scale the criteria we have, so that we can use it to define how important it is. after doing those, we can start like making our comparison matrix, and it will look like this. So we have value, we have the scale, as I showed in the table before, and like it will look like a comparison matrix after doing that. Right? And now is the result we have. So after doing the 3 steps, and we can find our first priority, which will be like this is like an example. So in this one, the final score looks like this. So leverage technology will be our first priority here. And now I have made it more complicated. So the second model I have is the FAHP with triangular fuzzy numbers. So it's very useful because one of the weaknesses of AHP is it can be too subjective. It might be subjective because the scaling table is made by people, right? So now here we combine fuzzy numbers concept to make the subjectivity less severe. Okay. So now before we move into the model, I will talk about a little bit on the fuzzy numbers. So I use triangular fuzzy numbers. So a fuzzy number is presented as L, M, and U. L means lower bound, M is middle point, and U is the upper bound. As long as the number falls into this range, then it's good. But as long as it's not in the range, then it will equal to 0. So this is like here, x will equals to 1, the mu of x, and in the middle, it would be like a score like here. And for the next one, if equals to u, then it's 0. So here are the 5 steps to build an FAHP model. So the first one is to define pairwise comparison matrix, which is similar to what we have before. However, this one is with fuzzy numbers. So I will talk about it. And for the step 2, is take an average on the comparison matrix. Because normally, when people do this, they will have a lot. They will recruit a lot of expert or professional people to do this, to do the scaling in order to lessen the subjectivity. But we don't have it here because I was the only one. Even I take the average, still it's mine. So, and step 3 is just a lot of math calculation. I will just like skip it. And step 4, because we have fuzzy, then we need to defuzz it. So I will talk about it and how we do it. And step 5, the result. Okay, so here still like as we remind, so fuzzy scale. So this is a scale 1. It's just similar to it's just the same as what we have before, but now we use the fuzzy number concept. So here is like lower bound is 1, upper bound is 1. But if the scale is 3, then our lower bound, the range will between 2 and 4. The lower bound is 2 and upper bound is 4. So yeah. And this is the difference between these two when we put that together. AHP is just like, it's just a value, it's just a number. And this is, yeah, it's also a number, it's fuzzy number, but it's a range thing, so it has 3 entries. And it's just normalization to do the calculation stuff, so I don't want to talk too much about it. So since we have falsified the number, how can we defuzz it? So M1 here in this case, we are now comparing M1 to M2, which we want to find M1 bigger than M2. So if the small M1, which is the middle point here, is bigger than the middle point of n2, mu of x would equals to 1 because it's more important than that and it's defined as 1. And however, if the middle point is smaller than the one that we are trying to compare to, which is n2 here, then it's defined as 0 because it's not that important as that. And however, if it overlaps, like here, which like even the middle point m1 is smaller than m2, however, the upper bound, the lower bound of m2 is smaller than the upper bound of m1, so they overlaps, which means somehow they are still like kind of connected. And somehow maybe it might have the chance to be more important than that. So we give him like partial credit. So after like it was like a comparison between two, and we would do like find comparison and find a minimum after doing all the comparison between the two values like D1, D2, DC3, and DC4, and now we have like everything, and we will choose the minimum one of that as our web factor. So the same like after deposit, we need to find the web factors. So it's just how we find the web factors. So the result will be this. So in this case, we have 0.5 and 0.5 and 0.274 at the bottom. So this 2 will be our first priority. It's fine if we have 2. Yeah. And the final score combines the weights for the criteria with the similarly constructed matrix of weights related to the bands. And here comes the conclusion. So this is how it would look like, because we have 64 countries, and I don't want to show everything here, but I just make a simple, I just randomly pick up 5, and it shows like the one that is marked as red is our first priority, and is given by the model of AHP, and on the right side is the result of the model of FAHP, which is fuzzy AHP. Yeah, and they actually have similar results. So the comparison between the results of the two AHP models, like 89% of their best recommendations for countries to improve are the same, right? It's here, it's like to change agriculture type and change agriculture type. And however, still 11% of them are different. So when I look into that, even though they are not exactly the same, but for the second recommendation, like the best result of one model will be correspondent to the second best result of another model. So it's like a finding, like these two models tend to suggest like well-developed countries to take the second and the third plan, which are to leverage the technology or maintain good relationship with other countries. And for countries that is underdeveloped, that have a tendency to suggest that they should grow more food with their lands, or like change the agriculture type, like change like from growing RPM to growing rice, and also maybe control birth rate if they have no choice. So this is the final like conclusion. Like while we still match with intuition, like you might think like, oh, Japan just do this, but this one can help us automate the process, which will allow quick decisions with only few inputs parameters. Yeah. And for the future work, as I said before, because this method can include some subjectivity. So that's why they have lots of professional people, experts to work together and take the average of that. So in the future, if I want to make it more accurate, I will definitely work toward that. Also, since this is like a preliminary step to do that, so I have this step, then I can go through like every detailed policies and references, and yeah, acknowledgement. I really want to show my appreciation to my academic advisor, who is also my thesis advisor, Lieutenant Colonel Libertini, and I learned a lot from her, like during the process. And I also want to thank to Colonel Carol, because she had helped me a lot to fix different problems or like minor issues I have before, because the model did not go like well like at first. Like there are some like small errors, yeah. And also I would love to thank to the faculty member of math, Department of Math, yeah, because that encouraged me a lot. And teachers here, I know like most of faculties of math department, and I also want to thank for everyone to participate in my honor thesis